Welcome. Boo! Happy Halloween. All right, we are starting a new unit. Not a new unit. We're still solving things in algebra, but now we're looking at something a little different. Instead of equations, we're looking at inequalities. Okay, so before we start solving these types of inequalities, we have to know how the heck to even work with an inequality. So when I say inequality, you should have something in that file cabinet in your brain that's telling you those are symbols. And inequalities are those symbols like less than, greater than. Now you might not have seen these ones, so I'll put them in a different color. This one would be less than or equal to. This has a little bar under it, which means this one is greater than or equal to. Then we also have not equal to. Hello. So we're going to look at hold on, I have people in my classroom. All right, I am back. We figured out what we needed to in here. All right, so we are graphing the inequalities. So that's what we're going to do today to prepare to solve them. So an inequality, like it says, it's a math sentence that doesn't contain an equal sign. It contains one of those symbols, less than, greater than, less than or equal to, greater than or equal to, and not equal to. And when we look at the graph of an inequality, that's when it's showing us all the solutions that satisfy that inequality. So let's look at some examples they gave us. In the first one, we're given an inequality, x is less than 3. So when we go ahead and graph what that means on a number line, you can see our special number here has a dot on it, but it's not shaded in, and that's super important to see that this dot is not shaded. Because in this case, x, our solutions have to be less than 3. They can't equal 3. So I use an open dot if it cannot equal the number. But then, as you notice, it shades into the left. So all the numbers that are less than 3 are solutions and will satisfy this inequality. So a number like 2.9999999999999 will satisfy that inequality because it is less than 3. So our solutions have to be less than 3. Okay, let's look at the second one they gave us. So you see what the inequality is, but can you read that? So over here is how you would read it. X is less than or equal to 3, as we said right here. So in this case, it's not just less than, it's less than or equal to, because it has the line under it. So now there's not an open dot at 3, there's a closed dot. And we use a closed dot if it can be equal to that number. So now 3 would satisfy this equation, this inequality. And so would 2.99999, and so would negative 0.01111112. Okay? So all these that are less than 3 or equal to it will work. Let's look at one more. Let's look at this one. X cannot equal 3. So, and there I just said it, x is not equal to 3. So when I show the solutions that would satisfy that inequality, everything is going to be shaded in except what? Except 3. So there's going to be an open dot at 3 to say, nope, can't have that, but you can have anything else. So let's try some of these. So let's look at an inequality that's given to you, like x, and I'm not going to say it, I'm just going to write it first. So now when you see this, you have to be able to read it. And this would be read as x is what? Less. Is it less than or equal to? No. It's just less than 2. And how do I know it's not equal to? Because there is no line underneath the less than sign. So now when I make these solutions to this inequality, the number that I want to make sure is on that number line is 2. Because that's my special number right there in my inequality. And then I'm going to see 1 above it, which is 3, and 1 below, which is 1. And then I'm just going to use arrows. I really don't need other numbers on there. Hold that thought. Makiko's in the room. Okay, I'm back. Makiko is done bothering me. So, so now on the number line, I am going to put a dot somewhere, and that dot is going to be at 2, but I have to think about if it's going to be open or closed. So to figure that out, I see that it's supposed to be less than 2, meaning it cannot equal 2. So I'm not going to use a closed dot. I'm going to put an open dot saying no, 2 cannot be a solution. And then I'm going to shade in what the solutions are. They're supposed to be less than 2, and I'm going to pick numbers that are less than that and shade in that arrow to say it keeps going that way. Those are all solutions. Okay, let's try another one. Negative. Okay, I am going to be easy on you at first and then try and trick you. So I'll be easy on you at first. So this one says x is, so I look at this, greater than or equal to, because now I have the line under it, the number -5. So on the number line, the special number is going to be that -5. And then I'm just going to go 1 up and 1 below. So if I go 1 up, 1 greater, I'm going to be at -4 because 0 is this way. And then I'll be at -6 if I go 1 less. And now I need to think about what kind of dot I'm going to use at this special number. And if it can equal that number, I am now going to use a closed dot to say yes, this time it can equal 5. And then if the values are supposed to be greater than, I have to think about, is -6 greater than -5? No, because it's negative. So I will shade to the right to say that these would satisfy that inequality and be true. Okay, now I'll try and trick you. So let's do something like -3, that symbol in x. The reason why this one's tricky, and maybe you can figure that out, is because my variable is now on the right. It's not on the left. So you're like, oh, that won't trick me. You'll see. So when I read it through, I'm at -3 is less than or equal to x. So -3 is less than or equal to x. -3 is less than or equal to x. If you don't like seeing it with the number out front, you could switch it around. So I could, and that's what I'm going to get you to try and do. It's always nicer to have the variable on the left. So I'm going to switch it, and I'm going to put the variable here. Put the -3 here. But if I switch those, then I'm going to have to switch this. So instead of less than or equal to, it's now going to be greater than or equal to. Because if I read it from left to right, it is less than or equal to. But now if I go from right to left, x is greater than or equal to -3. So when I read this one, x would be greater than or equal to -3. So now when I draw out the number line, I'm still going to have that special number of -3. That's not iffy. And now I need to go 1 up, 1 greater, which is -2, 1 less, which is -4, drawing my arrows. What kind of dot will I use? Well, if it can be equal to in either situation, it's going to be a closed dot because it can equal -3. And now this part, -3 is supposed to be less than or equal to x. Or if you think about it the other way, x is greater than or equal to -3. My solutions are supposed to be greater than or equal to -3. Greater than. So what solutions are greater than -3? Over here on the right. So I'm going to shade in over there. And if you think about the first one, -3 is less than or equal to x. -3 is less than or equal to all these other solutions. So this works out. So we're going to start solving some of these inequalities on Monday. See you then.